Hi everyone, welcome back to my channel Maths with Amita. I hope you all are doing fine. So let us continue with limits. So today we will be learning one formula that will be used in solving the problems. So what that formula is, that is given by a theorem, and the theorem says that the limit of ratio a to the power x minus 1 by x as x tends to 0 is equal to ln a. So this is what basically we will be using in all of our problems further on in today's session. Now, before proceeding to that, let me prove how did you get that. So a to the power x can be written as e to the power x ln a. The reason being, we know that a log f of x of base a is f of x. So basically, if you have base same as that of log, then whatever is inside log, that comes out as a function. Now over here, if you look very carefully, e to the power x ln a is same as e to the power ln a to the power x, and this is in base e. So actually you will get the same term as a power x. I hope this is clear to you. So after writing in that form, let us proceed further. Now further on, let us see what is the expansion of e power x. So e power x is 1 plus x by 1 factorial plus x square by 2 factorial. Next term is x cube by 3 factorial plus so on till infinity. So in this case, you consider this thing to be your x. So it is 1 plus whatever is the power of e by 1 factorial plus square of the previous term by 2 factorial plus cube of this by 3 factorial. Similar to this, you have to apply this formula till infinity. Now, while doing this, you have to keep in mind that a is greater than 0. The reason being that the domain of ln is positive numbers. So this thing, if we are going to apply, we have to make sure that the domain of ln is positive. So this is only possible when a is greater than 0. Now further on, now what we are doing is we are substituting the value of a power x from this into the actual limit that we are supposed to find. So when I substitute it, I can see that 1 and minus 1 will get cancelled, and you will be left with this term in the numerator and x in the denominator. Now from every term in the numerator, I can take x common, because you see the first term is having x, next term is having x square, next term will have x cube, so on and so forth. Now let us take x common. Once we take x common, it can be cancelled with the x in the denominator, and then you will be left with ln a by 1 factorial. Now 1 factorial is 1, so I am not writing it over here, plus here 1 x goes away, so you will be left only with x, and then ln square a by 2 factorial and so on. Now when I apply the limit over here, what will you get? Every term from hereafter will have x in the numerator only, and that will go to 0. So you will be left only with ln a. One more thing I would like you to observe here is, when you apply limit here, you will get a to the power 0 minus 1 by 0, which is actually 0 by 0 form, which comes under indeterminate form, and we know it can be solved further, and this is the method that we are using to get the answer. So we have made this into a theorem. Now one more thing let's keep in mind is, what if a is replaced by e? E is greater than 0. Yes, so we can apply this formula. So you will get ln e. Now the base is also e here. So what will you get? Ln e base e is 1. So either you remember this and you apply e, and then further on you can write 1, or you can directly remember. One more formula let us remember for this session is, limit x tends to 0 ln 1 plus x by x is 1. Okay. So today we will be using these three formula and the previous one that we have learned already. Now, one important thing that I would like you to note is, when you are solving this problem, make sure that whatever is the power of a, that should be in the denominator as it is. For example, if it is a to the power f of x minus 1 by f of x, limit x tends to 0. This is equal to ln a. First of all, a should be greater than 0, then only you can apply. And this is true only when f of x goes to 0 as x goes to 0. You have to make sure whatever is the power of a, first that should be in the denominator. Also, that power should go to 0 as x tends to 0. Then only you can apply this formula. So what people get confused usually is they think that the power can only be x. No, it can be even a to the power cos x, a to the power sin x, a to the power cos x minus tan x. The only condition is whatever is here as a power, that should be in the denominator as well, and it should go to 0 as x tends to 0. Same here and here also. Whatever function you see here, that should be here. For example, ln of 1 plus f of x. F of x can be any function, combination of different standard functions as well. Now, if I write like this is also 1, keeping in mind that f of x goes to 0 as x goes to 0. If this condition is satisfied, you can apply this formula as well. I hope I made it clear to you. Now let us move on to problems. Now let us see the first problem. So the problem that we have is limit x tends to 0, 3 to the power 2x minus 1 by x. Pretty simple problem. Now students ask that how do we know that we have to apply this formula? One thing that you can always see when you have to apply this formula is, you will have a number to the power some function. Also, you will notice that the power will go to 0 as x tends to 0, which is true. So, I can proceed with a to the power x minus 1 by x formula, because I can always bring x in the denominator. That's not a problem, because I can always multiply and divide by x. You can add, subtract, multiply, divide, all of the basic operations you can do over here as well. Now, let us see how we are supposed to do this problem. Pretty easy problem. So, I can see that it is in the form of a to the power x minus 1 by x. But the problem is, it's not exactly same. So, what I am doing is, I am just multiplying and dividing by 2 to make the power same. Now, I can apply limit to this function. Since this is constant, it will come out, and when I apply the limit over here, I will get ln 3. So this is my final answer. And you can take 2 in the power and you will get ln 3 square, which is ln 9. Is it clear? So most important thing to note is, it's not necessary it has to be just x. It can be any function of x. Now, let's come to the next problem. Right. I would like you to pause this video and try it by yourself. Once you are comfortable, you can come back and, of course, see the answer. Now, over here you see that you have a to the power x, you have some sine, and you have some ln. So, since we have learnt all these three formula, I will think of combining the three. So I have to apply a power x limit, then sine limit and ln limit. So I have three different formulas for them, right? Let me write what are those. So I have limit x tends to 0, a power x minus 1 by x as ln a. Also I have limit x tends to 0, sine x by x, that's 1. I have limit x tends to 0, ln 1 plus x by x, that's also 1. So what I can do is I can apply all these three formula over here. So this is the basic understanding when you get a problem. Okay, now let us see how we are supposed to do this problem. So I have done it roughly. What I am doing is I can see that I have 4 to the power x minus 1. Now I need to bring x because it should be same as a power. Now people get confused that why are we taking it like this. So what I will do is let me just erase this for you and then I will write it again. Okay, so how are we supposed to do this problem? Let's see. So I will apply limit x tends to 0. Now this 4x to the 4 to the power x minus 1 cube is same as this basically. Now I am splitting. Okay, then I am taking 1 by limit x tends to 0 sine x by p. Also you look very carefully, when you apply the limit you will get 0 by 0 form, which is an indeterminate form and which can be solved further on. Multiplied by 1 by limit x tends to 0 ln 1 plus x square by 3. Okay. Now for this what we have to do is, it's in product, so I can again split the limit. For this I need 1x. I need 1x for this. I need 1x for this. When I divide it by 3x, I am supposed to also multiply by 3x. Right? Now for this problem what's happening is I need x by p because I have to apply sine x by x formula. So whatever is in the argument of sine, that should be as a denominator. But when I am putting this as a denominator, I am supposed to even multiply. So I am dividing, I am supposed to multiply. So let me write it here. X by p is coming as in multiplication. Here what is happening? It is in the form of ln 1 plus x form. You can see very carefully, x square by 3 goes to 0 as x goes to 0, isn't it? X square by 3 goes to 0 as x goes to 0. So I can proceed and apply that formula. But for that I need to make sure whatever is here should be in the denominator. So what I am doing is I am multiplying and dividing by it. Okay, x square by 3, the product. Now when I apply the limit, you will see that this will give me ln 4, this will also give me ln 4, and this will also give me ln 4. So I will get ln 4 whole power cube. Right? Now let me cancel some things. So I can say x cube is here, and here x square and x will be x cube. So this will be cancelled completely, and you will have 3 is in the denominator, that is 1 by 3, that will go up. Similarly it is 1 by p, so it will go up. So you will get 3p. Also you can see when you apply the limit, this will be giving you 1 and this will also give you 1. So this is your final answer. I hope you are able to understand. If you have any doubt, you can write it in the comment section and I will be clarifying that in the next video. Coming to the next problem. This is one of my favorite problem. It's quite interesting. Now in this case, when you apply the limit, again you will get 0 by 0 form, which is again an indeterminate form. Right? Now if you look very carefully, what method can we use? We cannot use factorization here because there is no factor as such, right? I cannot even rationalize. There is no expression to rationalize here. I have some trigonometry. I can of course make use of trigonometry, and so also the limit is in terms of radian. So I can think of in a form of my trigonometry. In this case also you see it is in the form of 2 to the power some function. Let me see whether the function is going to 0 as x is going to 0. That's true. When x is going to pi by 2, minus cos x is also going to 0. So it is in that form. I can proceed and apply that, of course. But what's happening is when you apply, again you have to anyway do substitution. Right? Now what I do usually is, if I see a term which is creating problem, so I will consider that term as y, or in this case I am considering that as t. Why? Because only because x is tending to pi by 2, this thing is giving me 0. See, if you get 0 in the numerator, it's not a problem. But this term is giving me 0 in the denominator, which is creating a problem. So let me take that as some other variable. So I am taking that as t. Why I am taking that as t is because also I am taking x minus pi by 2. You can also take pi by 2 minus x. The answer will still be the same. You don't have to worry about that. Now here I am trying to make the limit to t tends to 0. Basically, I am more comfortable when the limit is tending to 0 or to infinity. Now in this case, when I take x minus pi by 2 as t, now as x tends to pi by 2, x minus pi by 2 tends to 0, that is t tends to 0. Now let me change the limit and write it here. So everything you have to substitute back in terms of t. Everything should be changed in terms of t. Once you take it back, now what is the power here? Cos pi by 2 plus t is minus sin t. Minus into minus is plus. So now this is what you get. Everything I have changed. Now over here what I did is, I got this form 2 to the power some function minus 1 and sin t is going to 0 as t is going to 0. But I need to make sure the power is same. So I am multiplying and dividing by sin t. When I do that, I already have one t here that I have put here. Now I have considered this as one limit. I have considered this as one limit and the next one as it is I am taking. Because the thing is, this is not creating a problem anymore. Right? When t is tending to 0, this function is not creating a problem. I will get pi by 2. So that is kept as separate. This you can very easily find it as pi by 2, not creating a problem. Okay. Now for this one, sin t by t when limit t tends to 0 is 1 and this is ln t. So this is your final answer. Alright. One more thing I have seen is what students do is whenever they multiply and divide by something, they don't consider that in the limit. They will just take it like a constant outside. No. Whenever you have any function which is having the variable as that of what is in the limit, you have to consider it inside the limit. You cannot take it out. Okay. Right. Now let's move on to the next problem. You can take 2 minutes to solve this problem. So the question is limit x tends to 0, a to the power tan x minus a to the power sin x whole divided by tan x minus sin x. Now let's see the solution. So this is the solution. Now in this case, if you see, what I am doing is, there is another way as well, okay. What I am doing is, I can see I have a form of a to the power x, some function which is going to 0 as x is tending to 0. So I just need 1 minus 1. So I am adding and subtracting. Now when I add and subtract 1, this one I am taking with this and this minus 1 I am taking with this. So I took minus common. You can see minus into minus 1 is plus 1 and this minus 1 is getting cancelled out, right. Now what I did is, for this numerator I need tan x. So I multiplied and divided by that, minus as it is here. For this I need sine, so I multiplied and divide. Now when I apply the limit, this thing will give you ln a, this thing will give you again ln a. This ln a and this ln a I am taking out as a common. Now you will be left with tan x minus sin x, which is same as the denominator. So it will get cancelled out, you will be left with ln a only. One another method that I have seen is, you can take a to the power sin x common. When you do this, you will be left with a to the power tan x minus 1 whole divided by, this is sin x minus sin x. Now you can see that the power is going to 0 as x is tending to 0. So it's not creating a problem, right. Okay. And this thing is same as the power. So when you apply the limit separately to this and this is in the form of a to the power x minus 1 by x. This will give you ln a. And when you apply limit here, it is sin 0 is 1, Sine 0 is 0. So you will get a to the power 0, which is 1. So 1 into ln a, again you will get ln a only. So this is another method that you can use. Taking out common to make sure the power, because you can see denominator is same. If I make, this is also going to 0. If I make the power as this and minus 1, I can apply the formula. Now next problem. You can pause. So once I said this common thing in the previous problem, I'm quite sure most of you will be trying to make that, which is correct actually in this case, because you have tan x minus x. If you take e power x common, this will be minus x. It will come exactly in the as previous problem. See, that's what we have done here. I took e to the power x. Also make sure in all the problems that I am doing, you are getting 0 by 0 form, which is an indeterminate form, and this is one of the methods. So this theorem that we did is useful for solving a problems which gives you indeterminate form. In this case, I took e to the power x common, so you will get this as a power. I hope this is clear why it is so, because a to the power m into a to the power n, when base is same, it is a to the power m plus n. You can check, when you multiply this with this, it will be x plus tan x minus x. This will get cancelled. You will be again ending with tan x only. Now in this case, you can apply limit x tends to 0, a to the power x minus 1 by x formula here, and you will get ln e. And here when you apply x tends to 0, it is e to the power 0, which is 1, and from this you will get what actually, because you are applying this formula now. So ln e is 1. So you are directly writing 1. So the final answer is 1. Right. Now this is the next problem which you can try by yourself, and we will see the solution for this in the next class. So let us quickly see what we have learned today. We learned one theorem which says that the ratio of a to the power x minus x when limit x tends to 0 is ln a. Also we have seen how did we get that actually, keeping in mind a is greater than 0. Also when you replace a by e, you will be getting the value as 1. Also one more thing we learned is limit x tends to 0 ln in the bracket 1 plus x by whole divided by x is 1. Also we made sure that this can be any function, but keep in mind that that should go to 0 when x tends to 0. Basically whatever limit you have, it's not just x tends to 0. Even if you have, let's say, limit x tends to a, okay, let me take this. Even if you have limit, let's say, x tends to b, a to the power f of x minus 1 by f of x, then it is equal to ln a if and only if f of x goes to 0 as x tends to b. So when the limit is going to that, whatever value is mentioned here, not necessarily 0, any value, then f of x should go to 0. This we have just now observed, right, in case of tan also. Okay, and then we have come across problem. This was very easy. Sometimes it will come as a combination. You have to apply the property of limit, where limit of two products can be separately found. In division also you can find, keeping in mind that limit x tends to 0, f of x by g of x is equal to limit x tends to 0 f of x whole divided by limit x tends to 0 g of x, only when the limit value of this is not equal to 0. And here we can see this denominator and this denominator is not giving you 0. So that's the reason I am applying that. And then we have seen that sometimes you have to do substitution, and after that you have to apply the limit. And then we saw how can we take common in case of trigonometry, and similarly here. So I hope you understood today's session. We did one concept, and next class I will be teaching you another concept and solving the problem that I gave you as a homework. Thank you for watching my video. Please like, share and subscribe.